Now we have different properties of the dot product that we need to go over. So if u and v are vectors and w are vectors, and k is a scalar, aka k is a constant like 2, and it's that multiplier piece, then these following properties hold. So they're commutative, which means you could do u dot v or v dot u, so any which way the vectors are, it doesn't matter. They're distributive, where you could do v plus w and then times the dot product of that and u. And that's the same thing as saying u dot product v plus u dot product of w. So that's distribution, so it follows that path. Scalar multiplication, it means that you can multiply, so k, any k value, that's our, I wrote example 2, times the dot product of u and v is the same thing as saying that scalar times u dot product v, or u dot product k times v. The next one is the 0 vector. If you do the dot product with 0, that means you're doing 0 times whatever, and that's always going to be 0. So don't even do the work, skip that, and just go straight to 0. And the other thing is that dot product and vector magnitude relationship. If you have a vector and you do the dot product with itself, it actually is going to give you the squared magnitude. So if I had a dot product, or if I had, a vector, and I needed to find the magnitude, I would go ahead, find the dot product, and then square root it to find it. So we're going to get into that into the next piece. So that's going to be on the next slide. So make sure you are at least aware of these, if not, have written them down.